A student came to register today, and at the same time bring in MSI to fix. This machine is turned on. You go quite far, so I'm going to enlist and I'm going to check on them. See what the cause is. Did you take it off and check it first? They say measure. I don't know what the source is. I'm going to take you off now. I'll fix it for you to see live. If you're wrong, I've done too much. Here, this one has the battery cable removed. Here. Very nice and men machine. This one is like GF65, right? Card 3 no 6 no. i5 jeans 10. The MSI asked you without knowing. I thought this battery was a ship battery, but it wasn't. MSI pin it flips out like this. The face that has the parameters is below. When you take care of it, or you want to take the machine off. If you want to unpack this battery, just leave both hands, both ends, just peel it up on the house. Here I see the hips. Looking at this enamel, it looks pretty. You guys look at the enamel, look at this shiny hip. I saw a friend ask the other day, on the Middleast forum, how to be able to identified the source block as well as the open source on a main without editing documentation. It's like I said, to understand the pattern that the document, we have to understand how the source blocks are arranged, and where to find the coils that the source block is designing. I'll say it again today. So you can see that this is the area of the input. A voltage input from the charging pin will pass even more fads with those big power parties. Well, you measure the one that's right behind you. Of those two fads, this is called carrying a load. If measured here, the resistance must be very high. And it tends to increase in infinity. Here, measure it for you. Do you see it growing? It's not 8, right? It's not 8. Usually at the level of not scoring 6 or more is temporary millet. Best of all, it will have to go back. Next is the position of the 5V 3V source. There's a source block that's very easy to identify. It's easier to identify than a 3V, 5V source. If you see the source of the cell, there's a gap. Easy to identify. Let's see which one is the one near the cell slot. So this is the prison coil. You set the measurement, and what you see here is prison power coil. When it's not in jail and when it's in jail, it's going to have different levels of resistance. It's plugged in. It's down. Here, I'll plug it in for you to see. See? If you plug in 2 bars, it will sparkle even lower. So here's the power coil. Here we have 2 coils, 3V and 5V. If the coil has no higher resistance, it is a 5V coil. This fruit. If it goes up to 0, it's probably not 8. This fruit. This is not a 6. This is a 3V district. And this is the 5V district. There's another way you can try measuring 8 vios. You 8-legged vios here, you see there's no 6. This one uses a chip. The power supply for vios is 3V. If these 3V, if you take it directly from the pulse source, the resistance will be equal. You see this county is, I didn't score 6 or 4, right? Not 6/4 like that. This roll is exactly a 3V roll, guys. This roll 5V. Here the power cup coil for this HM. This roll impedance is very low, but not over. It's not too late, it's not too late, it's not too late. Then we will have a power supply coil assembly for CPU female. This sucker is a little dry. I'll peel it off and replace it. Just unscrew it so you can see where the coil is. I just corrected myself. The student will see if it is. See if this is worth going to school. Sometimes you think it's hard to fix a laptop. Of course it's not easy, but it's not that hard to learn. You have a formal curriculum. Is that you'll learn right away? Okay. With a super source that's full of sources. It's going to be divided into 4 source blocks as follows. One is the VCO source block. VCO source block is granted to the processor kernel. Inside the CPU. Then this block will always be the one that has many face most, and the way it's designed is exactly the same. Here's 1, 3D's to fashion 3. And 1, 2, 3 these coils. These 3 coils, the index is 0, 2, Henry's 2. Microphone, you see these 3 scrolls. It's definitely a block. You measure here. You see no end, right? No end. As I have said many times in a live stream. Like video. If you measure this 0, you conclude it's short. You guys just go fix it, right? All these high-performance chips. You measure it with charcoal. About no. You can switch back to hugging and measuring. It's fine to measure 2 or 4 seconds. Usually you use 2 seconds. You measure. I'll put my eyes together first to get the sample index. What do you see? We can measure this. Impedance is not double hugging. If you measure on the coil, it's not double hugging. Then it's short. If it's higher, it's not that fast. Watch this. It's a 3 hugged comma. It's definitely not short, is it? Next, a roll of blocks. The particle on bow is the VGLX. This GLX block is. It has a design. The source is quite similar to the source V. You see, this is a remote that's very similar to my father. This child of source V Co. If there's a coil here, the different indicator is. It's not a 2-quadrant Henry microphone that measures the impedance. It will be higher. The impedance of the GBX coil, or VCC GT coil. It's higher than the V roll here, you see. Can't this roll go back? No, this one. And one of these two is going to be VCCI and VCCSA. It powers the power management block inside the CPU. The VCA will be higher. VCC GT, but which is lower than VexIO. You can see here that there's no comma, and this one will be this one. Not one of these. It's easy to identify, so we've identified the source blocks of the SU and it's all without a flicker. This is the source of Vega. Do you measure 3, not 6? This is not all coming back. Is that right? I moved on to measuring. Let's see how much experience there is. Hugging. As you can see, it's just higher than the non-floating cooler. Just a hug, but it's not short, guys. And here's the power coil for the A. That's the VRAM plug I measured here. That's not a pretty 12, is it? And this is an 8-volt dot that gives Vega. That is. I can't see that any source blocks are touching. If you do not touch, you are now new to power in for you to see. Where is it wrong? What is the source and what is lost? And I advise you that in the process of repair take off RAM. The guest seat. Because a machine that doesn't hit the source. You don't need a RAM, right? I removed it in the process of supplying the power I measured. I try to avoid affecting the knife sometimes. The customer's hard drive is very important. Unfortunately, we just left it. Just power it out. Power it on multiple times. It died the hard drive. Shock. Bad death. I'll activate the power supply, power it on. What you see is that the line doesn't jump 19. Eating stream non-19. This is definitely touching somewhere. And do you believe that watching the stream? Can I guess what's wrong? This one is definitely chopping the block. We'll do if I see 3 volts 5 volts. And maybe it's short. BA volt will do. Hey, guys, I've got a thermal camera on a 5 volt 3 volt IC. When you understand the circuit, you just have to look at the food line and you can guess. It's about 9% error. Sometimes you'll think I opened it and fixed it. I did it again and then. I made a video, right? But who's watching my live stream? Watch me fix it. You know I never have time. I have so much time to do that, right? Let's talk about it wherever we go. If you can fix it. If you can't fix it, you can fix it directly here. There's nothing to be afraid of, brothers. I have my own knowledge. Whether you can fix it or not depends on the machine. And now I will. Open up the heat cam and show it to you. Now I'm going to power in here. Power supply in. And now I'm going to show you the thermal cam. Here's the heat cam. It's not hot here, it's not hot. Have you seen the red IO? 3 volt IC 5 volt up to a 80° this and this IO heater. This is the IO here. You measure in the 3 volt 5 volt IC zone. Is to know immediately what kind of the foot A. 3 volts will do will alarm. I'll show you if I'm right or wrong. This is a 3 volt IC, 5 volt TPS, 1, 2, 8 years ago. Now I'm going to activate the meter. Let's show you. Measure to see if it is true that there are 3 volts. So if you look at the IC, you'll see foot number 3 and foot number 13. What you see is these are the legs of extinction. You measure here. As you can see, there are also people measuring this. See hips. That's interesting. That's it. Can you just poke the measuring stick through my eyes? I can't see the 2 heads, obviously. Put the measuring stick in here and measure it. This leg is stuck anyway. Right, no comma, no 4 is here. 12 foot level in. And this foot is 5 volts. That's 3 volts. If you are red, we know this one. Is it fast to die, guys? That's what I do. I've measured it for you. Guide you to measure from beginning to end. But this one's out for a minute. I already know where it's wrong. Power supply to main. Then I'll try to click the source to see if it works. Well, I unpacked the I/O from a main MSI saying, but main code it's different. If you can't hit the source, we'll have to reload the ROM. If there are many children, they still have normal sources. Now I'm going to show you something. The clock is up here. I ate the line before. 19. See how many circles there are, beautiful yet. No, 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 no. One is too beautiful. You always see hips. The trigger is off and it will re-trigger. That's a success, you see. Turn this light on. Then there's the pen phenomenon. Up. Do you see that? Always this. See no. Get inside this win. Then delicious. The most important thing is to test it now. Install the graphic here. If it gets enough graphics, it's a pop-up. We will check if we have received the graphics. There is display too. You see this one is RTX 3060. See if RAM has received enough. This one's 16, 2 and 8. 17 and 50 hours, that's the count. So we're done with this MSI. He came down to register for school today. And at the same time, let me fix it for her to see. Fortunately, they can fix it, not fix it. Turn the car around, right?